Welcome to our little video on measurement. Now, in the science lab, we're going to be using what is called SI. SI is French. It comes from the La Système International des Units, or SI, System International. We commonly call it the metric system in our schools in America. There are three forms of measurement that we need to be familiar with. There's linear, which is along a line, volume, which is how much space something occupies, or liquids. Again, it's how much space something occupies. For linear, the basic unit of measure is what we call millimeters. In volume, we use what is called cubic centimeters. And in liquid, we use milliliters, is the basic unit of measure. So you have the meter, the cubic centimeter, and the liter for your units of measure, with milli being the smallest. For weight, we have something called the gram. Now, here's the thing about weight in the metric system. In the metric system, there's a spot where 1 gram, or weight, is the same as 1 milliliter of water, which occupies 1 cubic centimeter of space. So you have a spot where weight, liquid, and linear measurement all come together to equal the basic unit for each one. It's kind of a cool thing. So if we look at this again, linear measurement means on a line, or the distance on a straight line. And we use this to measure solids down each side. Then we have, whoops, let me get that in front of there. Then we have gas and liquid measure. Now, both of those are what we call volumes, or how much space does either the gas or the liquid occupy. Think of it like a box, and we're trying to fill a box up. So again, volume, how much space it fills. In the case of gas, we use cubic centimeters. So gas filling a space, kind of like a balloon. How many little cubic centimeters would that fill? Liquid is used, we use the term milliliters. And that's for liquids, because if we just pour a liquid out on the tabletop, it's going to make a puddle. And we want something that's a little bit more scientific to do our measurement. So here we are. We're going to walk around the lab. Here's our beautiful lab, everybody. Okay, we're going to go over here to a display I've set up. Here are some of the containers that we use to measure liquids in our classroom, in our laboratory. Some of these you've seen at home. I think all of you have seen what we call measuring spoons before. In the case of these spoons, as you can see, we have both the imperial, or the tablespoon, and we have the metric. In this case, 1 tablespoon is the same as 15 milliliters. But we also have these things called measuring cups. In this case, this cup has the metric measure right there in milliliters. Then we have our ounces. That's our imperial measure. 16 ounces, of course, equals a pound. And then we have the imperial measure of cups. So in the imperial or American system of measure, there's no place where 1 cubic inch filled with water equals 1 ounce, and it just doesn't work that way. Instead, we have 12 inches equals a foot, 5,280 feet equals a mile, 16 ounces equals a pound, 2,000 pounds equals a ton. It gets very confusing. So we're going to be using the metric system because it's easily divisible by the number 10. It's easy to move the zeros around and keep your numbers straight. All right, these right here are called graduated cylinders. We have these down here that go down just 10 milliliters. This one's a glass one that's 10 milliliters. This one's 50 milliliters, 100 milliliters, 250, all the way up to this big boy right here. He's 1,000 milliliters, which is the same as 1 liter. If you go to Albertsons or Walmart and you buy a 1 liter pop, that's what you're getting. These here are called beakers, and we have them all the way from the little teeny tiny baby one here, the 50 milliliter one, all the way up to this big one right here, which is 2,000 milliliters, or 2 liters of capacity, 2 liters of volume. These here in the middle are called flasks, simply because of their shape. And again, these are all labeled. In this case, this is a 225 milliliter container, and we can use these to measure liquids, and we will use them in our laboratories. Now, if we go over here to my next display, I've set up some colored water for you, because how do we read these things? You know, do we just put it up to the line and we look there and we go, well, that's between 100 and 150, so that must be about 125 milliliters. Well, liquids, if you look across there, let me see if I can turn that, there we go, just a little bit. If you look across there, there's kind of a ring around it, because with liquids like to try and climb the sides of the container. If you look here, you can see this. It's kind of got a concave shape to it, like a contact lens that some of you wear. So when we're reading these, we must be very careful. You can see it very clearly here on the video. The sides are higher than the middle. So when we're reading this, first off, the lines that are underneath the numbers indicate the number of milliliters, whole units, in this case 8. Then there's 5 lines in between, so each one of these is worth 2, because 2 times 5 equals 10. So in this case, we have 8 plus 2 more, so it's 8.4 milliliters of liquid. And we have to be careful when we're reading these that we're reading the bottom of the curve and not the top of the curve. In that case, that one was about 150. But now, I wanted to show you that I have the triple beam balance set up. It's called a triple beam balance simply because there's 3 there, triple meaning 3. And I've zeroed this one out to show you that it's empty. It's set at 0. And what we're going to do is we're going to take one of our 10 milliliter graduated cylinders, little plastic one, and we're going to set it on here, and we're going to zero this back out and get the scale line to come back down to 0. I've already done this, and I know that it's about 3 grams. So I set that up at 3 grams. The singles are in the front, the tens are in the back, and the hundreds are in the middle. That's just the way this one is made. So I set that one up at 3, and it zeroes itself back up. Now I filled the second one here with 1 milliliter of water, and I've put a little drop of red color in it. It's 1 milliliter of red color. You can see right there that the bottom of the curve is right at the 1 line. So now I'm going to take this off. I'm going to take this off. I'm going to set this on here, and I'm going to show you that 1 milliliter of water, which occupies 1 cubic centimeter of space, which is measured linearly, is going to be equal to 1 gram of weight. So I'm going to run this over to the number 4. I'm going to add 1 gram to it. There we go. I've added 1 gram from 3 to 4, and guess what? It zeroed out. So indeed, 1 cubic centimeter or 1 milliliter of water is the same as 1 gram of weight, because we've checked it on our scale and we have proven scientifically that this is indeed the case. So remember, we're going to be doing some exercises in class on measurement. You'll be coming to the lab to play with these different things. I guess not play with them, but you're going to be using these to measure and see if you too can figure out how to measure liquids in the laboratory, as well as lines on paper and lines outside.